All right, today we're going to work on a solution stoichiometry problem that involves limiting reactants. And here's our problem. How many grams of silver chromate will precipitate when 0.15 liters of 0.5 molar silver nitrate is added to 0.1 liters of 0.4 molar potassium chromate? So we've got these two solutions. There's a certain amount of mass of each of them in their respective solutions. So like I have a beaker that contains a certain amount of silver nitrate that's dissolved in water. I have another beaker that has a certain amount of potassium chromate that's dissolved in water. And when I mix them together, those ions are free to float around and they make this insoluble product. I'm wondering how much of that insoluble product I will make. And I will need to calculate how much silver chromate can be produced from each of those reactants. And I will be limited in my amount of product by the reactant that runs out first. So I need to calculate how many grams of silver chromate each reactant can produce. So I'll have two stoichiometry problems to achieve that. So let's start with our silver nitrate. It says we have 0.15 liters of that silver nitrate. I'm going to start with my volume because I'm going to use my molarity as a conversion factor as we did last week. Now, the other thing we know about the silver nitrate is its molarity. It's 0.5 molars, which means it's 0.5 moles for every 1 liter. And my liters will cancel with the liters from my starting number. Remember, every time we do stoichiometry, something is canceling out until we are at the unit that we like. All right, my next step now is to relate that silver nitrate from the balanced equation to the silver chromate. And this is a 2-to-1 ratio. So I will use that for my conversion factor here, my mole ratio. So for every 2 moles of silver nitrate, I will produce 1 mole of silver chromate. Now I'm in moles of silver chromate. I want to go to grams, and I know that 1 mole of silver chromate weighs its molar mass. So I have to look in the periodic table, 2 silvers, 1 chromium, 4 oxygens. I'm getting 331.74 grams. I multiply everything in the numerator, divide by everything in the denominator, and I get 12.4 grams of silver chromate. So that's how much can be produced from my starting amount of silver nitrate. But remember, it takes both reactants in order to produce some product. So I need to know how much product my other reactant can make as well. So I will do another stoichiometry problem, this time also starting with my volume. 0.1 liters of potassium chromate, K2CrO4. I'm going to use that molarity as a conversion factor. I know that there's 0.4 moles in every 1 liter of this potassium chromate. That unit will cancel. Now I want to relate my potassium chromate and my silver chromate. I know that for every 1 mole of potassium chromate, there's 1 mole of product produced. And for every 1 mole of silver chromate, it will weigh 331.74 grams again. Now I'm ready to solve. I multiply everything in the numerator, divide by everything in the denominator, and I get 13.3 grams of silver chromate. Now remember, when I'm trying to decide now how much product will I actually make, I can only make the smaller amount, because once that reactant runs out, once that reactant produces that amount, the reaction would stop. So I'm going to be limited to making only 12.4 grams of silver chromate. And when I look back, I see that the silver nitrate is the reactant that limited my reaction. So my limiting reactant is, let's write that. Is my silver nitrate. And my theoretical yield is 12.4 grams of silver chromate.